So here we have a graph of the normal distribution. It's a nice, smooth, bell-shaped curve. Note this thing here, it doesn't really end. It keeps going right off the board. The curve extends out to infinity without ever touching the x-axis. Why? Because there's no real limits in the normal distribution. You can't say, oh, what's the tallest a person can be? Well, a person can be 7 foot 6 inches, but a person can't be 7 feet 7 inches. That's not how it works. There's no cutoff. So it keeps going, it just gets closer and closer. If you've had calculus, it approaches asymptotically. The total area, the total blue area here is 1. Why? Because it's a probability distribution. The normal distribution is a probability distribution, and probability distributions always add up to 1. Specifically, it's a continuous distribution. Now, sometimes we like to chop it up vertically and consider the area in particular regions of the normal distribution. For example, you wouldn't ask what's the probability that a man is exactly 6 feet tall. You might want to ask what's the probability that a man is more than 6 feet tall or less than 6 feet tall. The normal distribution can help you do that. Now, take out this table, the normal distribution table. It looks like this. This is the first few rows on the positive side of your normal distribution table. Across the top, 0.00, 0.1, 0.2, and so forth. And wait, why do we have this giant box of numbers? Well, remember Z-scores? You know, Z, value minus mean divided by standard deviation? Well, we'll get back to that soon. But this tells you the area to the left of any particular Z value under the normal distribution. So if your Z value is 0.12, that's 0.12. There's only one column, really. Let me show you how it works for some specific numbers. I want to find the area to the left of negative 1.65. So turn it over to look at the negative side of the table. And you look down the Z table to row negative 1.6. And you look across to 0.05, and where they meet, you find the number 0.0495. That's your answer. Now, find the probability that a Z-score is less than 1.73. This is a probability distribution, so that's what area means here. Area means probability. The area under the normal distribution is the same as the probability that a Z-score falls in that range. So we look up 1.73 and we get 0.9582. What if we want to know the probability? What if we don't want less than? What if we want more than? 1 minus the table value gives you the probability that Z is more than a number. How about the probability that a z-score is between two numbers? What do you think we should do here? We look up each one of them and subtract. Negative 0.83 gives us 0.2033. 1.08 gives us this. Your answer should always be positive. You can always do the smaller number from the bigger number. All right, we good so far? You can look up a number on the table to tell you the probability that a z-score falls in a particular range. That's what the table tells you. Now, I don't know about you, but I haven't met too many z-scores walking down the street. I've met people and cats and rocks, dogs, trees, not z-scores. So we need a way of turning real data into z-scores.